Can you imagine a steel plate 40 centimeters thick, 400 mm, the 400 mm. Now imagine that this thickness can be cut with light. As you know, at FORZA Laser, we are specialists in fiber technology for cutting metals, and we always bring you the latest news. And now the greatest milestone, they cut 410 mm of black steel. We are indeed living in the era of high power in lasers. In 2004, 20 years ago, a 1,500 watt machine could cost up to $800,000. Nowadays, this same machine with this power can cost only a fraction of the price, around $40,000. Imagine the price ratio for 2014. 10 years ago, we generally saw in the industry an area of 1M 50 by 3M with a nominal power of 500 watts. It was what the industry needed or what could be afforded last year. In 2023, we heard the same news, but with 60,000 watts, claiming the highest power in the world. Now 60,000 watts cuts more than 2 inches. And today, this year 2024, in January, Raikus launched its 120,000 watt laser source. This just happened in January of this year, where they managed to cut 30 centimeters, 300 mm of black steel. And just about 3 months ago, BWT, which is another Chinese company that also manufactures laser sources, launched its 2001 135,000 watt source. I can't even imagine how much that is, but they managed to cut 410 mm of black steel with oxygen. This news was reported in Yinal more than 3 months ago between the company BWT, which manufacturs the lasers, and FSCAT, which manufactures the heads. Interestingly, these two companies are Chinese. In fact, Raikus, which also launched the 120,000 watt source in January, is also a Chinese company. And the fact is that the laser source cannot exist without its head to be able to make a cut. In fact, let me tell you that BWT has already launched its new 150,000 watt source, but they can't achieve higher powers if the heads don't exist, because the heads are also a complicated technology, as at high powers, they heat up more. And the level of technology required to control a good cut at those power levels is quite demanding. Both have to coexist, and that's why these unions are made. And before talking about the advantages, let's talk a little about the challenges. When we talk about 12,000, 20, 30, 40, 50, 120,000 watts, there are certain important challenges that need to be taken into account. First, as the power increases, the lenses start to heat up more because, of course, nothing is 100% efficient. So with the lenses, there is a part of the light that doesn't pass through and transforms into heat. And with such high powers, the lenses can easily explode. That's why temperature control is absolutely mandatory. Here, at these power levels, errors are also much more dangerous because there is a greater release of sparks. The behavior of this type of power is a bit more complex to control because you have a 400 mm section that you need to maintain continuous control over to make a cut. Well, the piercing is also very variable. If you watch the video, the cut starts from the outside because the piercing is an extremely complicated challenge, right? And companies like ours are the ones dedicated to doing exactly that, conducting all those tests to achieve perfect piercings so you can simply press play and cut. Another important thing is the complexity of the parameterization. Here, I have rated it as legendary because in addition to the normal parameters like speed, pressure, focus, type of gas, and a countless number of other parameters, additional ones are also added. Here at high powers, we already have new nozzles. It's no longer just the simple and double ones. There are special nozzles that help us direct the gas differently. Also, regarding gases, now mixed gases can be used, which perhaps before we only heard about nitrogen, oxygen or air, but now we also hear about 1000th ninth gas or a mixed gas. And on this topic of the 1000th ninth gas, which is a completely new gas, we are going to release a video from FORZA Laser, so subscribe so that when we release it, you will receive the news. And to talk about the advantages of having high power, I would first like to start with the geometric temperature limitations when we have relatively low power. Here I am showing you an example of one of our clients who has a 3000 watt machine that, although it does cut 3/4, in fact the top left figure is very good, it is a bit complicated to cut small figures that have very tight circumferences or figures that are very close together. Why? Because we are working at the limit, which is what 3000 watts gives me to cut black steel. 3-4 is at the limit. The material heats up, so I won't be able to make small details. So I have to understand that when I talk about limit cutting, it means I can make a line, a square, a large circle, pieces that don't concentrate the heat and melt, and that these things happen. Is it common to hear people say, Diego, you know what? I'm going to wait 3 years because for sure the laser will drop in price? Probably yes, but you will miss the opportunity to take advantage of this technology today, which is already accessible, no longer costing thousands or millions of dollars as it did before, which you can buy and recover the investment because there is already an industry that needs to cut these thicknesses. When we move from 6000 watts to 20000 watts, we can achieve 96% more productivity. You can literally produce almost twice as much from the same plate if you had 20,000 watts instead of 6,000. That's just talking about the jump from 6,000 to 20000 watts. And what does that mean? If you already have large productions and it takes you a whole workday, 12 hours working, hey, with the other machine it only takes you 6, right? And the same thing happens when we switch from 20,000 to 30,000 watts. Look here, as you can see quite clearly, cutting a 2-inch plate, we can achieve approximately 61% more in productivity when using 30,000 watts. Obviously this is very good. It seems that the speeds are relatively slow, but in terms of time it is important. It's not the same to take 10 hours of work as, 5 hours, 6 hours, so there's already a significant improvement. Here I have a small table to give you a general idea, for example, of how working with Jardos, which is a black steel material, functions at 20, 30 and 40,000 watts. You see that with different thicknesses, I always have higher speed while cutting, which is one of the special characteristics. And the gas also influences the cutting capacity of 2001. It is not the same to have a 30,000 machine and use oxygen as it is to use air. Remember that we have oxygen for hot cutting, air, nitrogen, or mixed gas for cold cutting. Cold cutting can go much faster. And how much productivity? Up to 5 times more if they work with air versus working with oxygen. In fact, here we have a small table showing the different uses, right? From the 1009th gas, air, oxygen cutting with 30 mm, I have 84% more productivity if I cut 20237. If I cut 12,519% more productivity, I can cut up to 5 times faster if I use air. And with that, I'm done. If your budget definitely allows for a quick conclusion, significantly increase the power. If they are working with thick materials, we tell our clients that if they have the budget, the power won't be excessive. It will allow them to cut faster and make smaller shapes because the material won't be able to heat up. And obviously in general terms, they will be more productive overall and recover the money more quickly. And finally, it is worth noting that at FORZA Laser, we are not directly tied to any particular brand. While it is true that almost more than 90% of our current machines have max photonic sources, we are not limited to using other brands of sources. In fact, this is a clear example. For instance, if a customer comes in needing 120,000, 135, 1000 watts, we will use BWT, which is at the forefront of technology, and we will incorporate them into our machines. Thank you very much for joining us in this video, and I'll see you in the next update or news about laser technology. Bye-bye.